First of all, we'll be discussing the question in this video, then we will discuss the approach, how to approach this question, and finally we will be discussing how to write the actual code in exam for this particular question. So let's make sure that you are watching this video till the end, because this particular question is slightly on the hard side and not many of you were able to solve it. So make sure that you are watching this video till the end. So now let's start by first reading the question and understanding it. So question here is, infinite number of people are crossing a 2D plane. They march in such a way that each integral x coordinate will have exactly one person who moves along it in the positive y direction starting from x comma 0. You have to implement the function. The function takes an integer matrix barrier having n rows and 3 columns, where n denotes the number of barriers. The ith barrier is defined by xi, yi, di, which means that the barrier is blocking all the people who want to pass through points lying on the line segment connecting xi, yi and xi plus d, yi. Once a person encounters a barrier, he stops. So you will have to find out the number of people who will be blocked at some point while marching. I know and I am 100% sure that you would not have got this question. So don't worry. If you will read line by line and then try to understand it line by line, you will be able to understand it. So again, let's just read first line first. Infinite number of people are crossing a 2D plane. They march in such a way that each integral x coordinate will have exactly one person who moves along it in a positive y direction starting from x comma 0. Let's understand with the help of this diagram. So this is a 2D plane, x-axis and y-axis. So each person, so on the x-axis, each number, that is 1, 2, 3, 4, 5, this denotes the person. So one person is standing at one position, one person is standing at two position, one person is standing at three position, and so on. So here it is written that one person who moves along it in the positive y direction starting from x comma 0. So every person will start from these points. So first will start from 1, then from 2, then from 3. So each person will start from these points towards the y-axis. So this is, if a person is standing here at 1, so he will start moving towards the positive y-axis, that is upwards. Okay, and this will happen at each and every point of this x-axis. Till now it's clear, I hope. Okay, next, what we have to do, the function takes an integer matrix barrier having n rows and 3 columns, where n denotes the number of barriers. So these are the barriers. These are two barriers. These lines represent two barriers. Okay, and our barriers will be given to us in the manner xi, yi, di. So here if you can see that 2, 3 is the starting coordinate of the first barrier, and 3 is the length of that barrier, that how long is that barrier. Next again 4, 6 is the starting point of this barrier, and 4 here is given as the length of this barrier. Okay, so these are two barriers that are given to us. Now, as I have told you that every person will start from these points and it will move towards the positive y-axis. So let's suppose there is a person who is starting from 1. So when the person is starting from 1 and he starts to move in a positive y direction, then he will keep on moving and there is no barrier present there. Okay, so one person at first position will keep on moving without any barrier in it. But people at moving at 2, 3, 4, 5, let's just talk about 2, 3, 4, 5. So they will start from these positions and they will start moving in the positive y direction, and once they face this barrier, they will stop because they have faced the barrier and they will stop. Next person standing at 6, 7, 8, 9, they will start moving, and once they face a barrier at the position 6 in the y-axis, then they will stop. So we have to find out the number of people who will be blocked at some point while marching. So we'll have to tell the number of people who will be blocked once they are moving. So here how many people are there who will be moving, who will be stopped. So person starting at 2 will be blocked by this barrier, 3, 4 and 5 will also be blocked by this barrier only. So total here are 4 person that will be blocked by this barrier. Next is 6, 7, 8. So when the person will start moving from 6, 7, 8, it will move towards the positive y-axis and it will be blocked by this barrier. So total 3 more, that is 2, 3, 4, 5 by this barrier and 6, 7, 8 from this barrier. So total of 7 people will be blocked by these barriers that are given to us. Okay, and again the answer for this particular diagram will be 7 only. and these barrier informations are given to us. So n stands, so assumption n is greater than 0, that is the how many number of barriers will be there, and length of barrier is d greater than 0, that is this length. 3 and 4 denotes the length. Okay, and overlapping of barrier is possible. So here you can see these barriers are overlapping at some point. At 4, 5 these barriers are overlapping. So what all will be given to us in the input? In the input we will be given the n, that are the number of barriers, in this case 2. Let's just see the example, it will be more clear. So here this is what the input will be given to us, that is n equivalent to 2, that is the number of barriers. 2 barriers will be given, and then the information about the barriers will be given, that is x comma y 2, 3 and d is 3. So for barrier 1 x y is 2 3 and d is 3. So x comma y here represents the starting coordinate of this barrier, and 3 here represents the length of this barrier, that it will continue till the length 3, that is till here 5. Next barrier 2 information will be given, that is it will start from coordinate 4 6 and it will continue till 4. Okay, so these two informations will be given to us, that is number of barrier and the information of the barrier starting at the d part of the barrier. Okay, and again here are the explanation that is given, that first barrier will block people from 2 3 4 5, the second barrier will block people from 4 5 6 7 8, but here 4 5 are common and only one person is standing at a one particular point, so he will be blocked either by first barrier or by second barrier. So total number of people that will be blocked by these two barriers will be 7, and 7 is our output only. So I hope now the question is clear to you. It is very simple. The person will start moving from x point in the positive y direction, and if he face the barrier he will stop, and we have to just tell that how many people will be stopped by the barriers that are given to us in the question. So I hope now the question is clear to you. Now we will move towards the approach. So let's move towards the approach of this question. So guys, now let's just discuss the approach. For discussing the approach, I have made this diagram and I have tried to cover each and every possibility of the barriers that you can have in this particular diagram. So guys, do subscribe this channel, because I am making a lot of effort to make you guys understand how this question is working. Okay, so here what is given? It is given that n is equivalent to 5. So n is equivalent to 5 means there will be 5 barriers given to us. So there is barrier 1 2 3 4 5, and the information of barrier will be given in this way, that is x y d. So x comma y represents the starting coordinate of the barrier and 3 represents the length of that barrier. So if we will see an example, so here barrier 1 is starting from 1 2, so this is 1 2 and d is 3, that is the length is 3. Similarly, if you look barrier 5, it is starting from 11 3, that is this 11 3 and length is 2. Okay, so I hope now you have got it, that x comma y is the starting coordinate of that barrier and 2 is the length of that barrier. So 5 barriers are given to us. So how we will approach this particular question? So first of all, our aim should be to what we have to do, to overlap these lines. So here you can see that we have to find the unique lines. So our first aim should be that we have to find unique lines that are not overlapping to each other. So if we will consider first barrier, so first barrier is not overlapping to anyone. Okay, so we will move ahead. Now we will see the second barrier. Second barrier is overlapping to first barrier. So what we will do, okay, so what we will do, we will merge these two barriers. Okay, so let me just draw it. Okay, so I am just currently talking about the approach. I am not writing any code. So here what we'll do, first barrier is doing nothing, our second barrier is overlapping to our first barrier. So what we will do, we will simply merge these two barriers like this. We will simply merge these two barriers like this, and we will make these two barriers as one. Starting point will be 1 and ending point here will be this 5. Okay, starting point as 1, ending point as 5. So we have merged these two barriers. Now if we will check, no other barrier is what you can say overlapping this particular barrier. Now we will move ahead, and we have found that this particular barrier. So is this barrier overlapping to any other barrier? So the answer is no. So what we will do, we will again leave this as it is, and we will consider this as a single barrier only. Okay, so consider as a single barrier only. Next, if we will move ahead, we will see 9 3. So this fourth barrier. So is this fourth barrier overlapping with any other barrier? So the answer is no. This fourth barrier is not overlapping to any other barrier. But when we are moving ahead and we are seeing that this fifth barrier, so is this fifth barrier overlapping to any other barrier? So answer is yes. So it is overlapping to fourth barrier. So we'll consider this entire two barriers as a single barrier like this. Okay, and its starting point will be from 9 and ending point will be to 13. We will reach I will tell you later that how we are finding the starting point and the ending point. So now what we have done, we have these three barriers. Okay, so merged the overlapping barriers, and now we have the three different barriers, and now these three different barriers are not overlapping to each other. Now what we'll do, now we will check that how many people are blocked by this barrier, how many people are blocked by this barrier, and how many people are blocked by this barrier, and we will simply add those numbers and we will return the answer. So it is that simple. So first step is to merge all the overlapping barriers into a single barrier. By doing this particular step, we will find all the non-merging barriers. So here we have found out that in the end, three barriers are such that they are non-merging. Okay, and then we will just find out how many people have been blocked by first barrier, then how many people have been blocked by second barrier, then how many people have been blocked by third barrier, and this will be our answer, and we will simply return it. Okay, so this was the high level of the approach, that how we will be moving ahead. But now how to do it, how to merge these two barriers, how we will know how to do all the calculations, how we will merge these two barriers. So let's just start step by step. So let's just forget currently that we have some overlapping barriers. Okay, delete it, delete it, delete it. Okay, our first step should be, let me write somewhere here if it's visible, or let me just quickly increase the font size, 16. So yes, so let's just focus on our first barrier. For every barrier, we will have to find the starting X point and the ending X point. So for there are 5 barriers, so we will have to find 5 starting point and ending point for 5 barriers. So for the first barrier, what is the starting point, starting X point? So again, starting X point is given to us in the barrier information only, that is 1. Okay, that is 1. Now we have to find the ending point of this particular barrier. So what is the ending point of this particular barrier? It is starting from 1 and it is stretched in the X direction with the length 3. So it will be 1 plus 3. 1 plus 3. So if I summarize this, to find the starting X point and the ending X point of the barrier, what we have to do? We have to simply do xi. This will be starting point, and we have to do xi plus d. So this is the starting point and the ending point of the barrier. So so what we will do, using this particular formula only, we will find the starting X point and ending X point of all the barriers. So overall, we will have the starting and ending X points of 5 barriers. So let's just quickly find out those first. Okay, so for first barrier, starting point is 1, ending point is 1 plus 3, that is xi plus d, that is 1 plus 3, that is 4. For next barrier, there is starting point is as 3 and ending point is 3 plus 2, that is xi plus d, that is 5. Then again for the third barrier, the starting point is 6 and the ending point is 6 plus 2, that is 8. Again, if the starting point for the fourth barrier, starting point is 9 and the ending point is 2. Oh, sorry, 9 plus 2, that is 11. Okay, next for the fifth barrier, the starting point is 11 and the ending point is 11 plus 2, that is 13. Now we have gathered the starting X point and the ending X point of each of these barriers. But now you will ask why we have done this. So again, the answer is very simple. So we have found the starting X point and ending X point of each of the barriers so that we can merge the overlapping barriers. So it will help us in merging the overlapping barriers. So if you will look closely, you will see the starting point of second barrier, that is 3, is less than the ending point of the first barrier, that is 4. So therefore we know that these two can be merged. So therefore we have found the starting and ending point of the barrier. Okay, so our first step is over. So this is our simple first step. After finding this, what we will do, we will simply store this in an array. So again, we will form an array of size 5, and each of the array element will contain two values. It will be a 2D array, and each array index will contain two values, that is starting x point and ending x point of that particular barrier. And why we have found the starting and ending x points of barrier? So that we can find the overlapping barriers. Okay, so this is our first step, that is over. Now we have stored this information in the array. Now what will be our second step? Second step will be to merge the overlapping barriers. Second step will be to merge the overlapping barriers. Okay, so how we will do that? Just a second. Sorry for this one. Okay, so here you can see that now now we will be merging using this particular thing. We will merge the overlapping barriers. Okay, so what we'll do here, we will see that what is the starting point of the first barrier, that is 1. Now we will see, is the ending point of the second barrier less than the starting point of the second barrier is less than the ending point of the first barrier or not. So if it is, in this case it is, so it means that these two barriers are overlapping, so we will merge it. So how we will merge it? We will simply take the first position and then we'll take the fifth position. So this will be length of the overlapping barrier, that is 1 comma 5. So this is the starting and ending point, starting x point and the ending x point of the first overlapped barrier. Then again we will compare the third barrier, whether this third barrier is overlapping with this 1 comma 5 or not. Again, is the starting value of this barrier less than the ending value of this barrier? The answer is no. So it means that this particular barrier is a different barrier. So again we will take it and we will do starting point 6 comma 8. Okay, now again we will compare this particular barrier whether it is an overlapping or not. So we will again check whether the starting x point of this barrier is less than the uh, ending point of the previous barrier or not. So in this case it is not. So again we will consider this as a single barrier. It will give us 9 comma 11. Again we will check whether the starting point of this barrier is less than or equal to the ending point of the previous barrier. In this case the answer is yes. So it means that these two barriers are the overlapping barriers and we have to merge these overlapping barriers. So what will be the starting and ending point of these overlapping barriers? Starting point will be the starting point of the first barrier, that is 9, and ending point will be the ending point of the merged barrier will equivalent to the this one 13, 9 comma 13. Now what we have done, we have merged these overlapping barriers and we have found out that there are total 3 barriers that are present over the x-axis, and now no such overlapping is present. Now our last step will be to find the number of people blocked. So what we'll do, we will first check how many people have been blocked by first barrier, then how many people have been blocked by second barrier, then how many people have been blocked by third barrier. So the answer is simple. To check for the number of people blocked by first barrier is simple it is. So we will take this y point. Okay, so we will take this y point minus x plus 1. So we will follow this approach. Okay, because one total point, number of people that have been blocked by this barrier is 1 2 3 4 5. So 5 minus 1 plus 1. So here it will give us 4. So the 4 people have been blocked by first barrier. Then 8 minus 6 plus 1, that will give us 3. 3 people have been blocked by second barrier. Then 13 minus 9 plus 1 will give us 5. That is 5 people have been blocked by 1 comma 5 people. Sorry, here it should be 5. Okay, 5 3 and 5 people have been blocked by third barrier. So total will be 13 people that have been blocked by all these barriers. So here we have given the output as 13. So this was the entire approach. We have to follow step by step. And now if you have still not understood, make sure that you watch this approach again. You will surely understand. And still, if there are some doubts, let's move towards the coding part and there I will explain it clearly that how we have to merge the overlapping barriers through code. Okay, so let's just quickly move towards the coding part. Okay, so guys, for saving time, I have already written the code. I will explain this code line by line to you, and the thing will become crystal clear to you. Just remember the steps I have told you: step 1, step 2, and step 3. I have told you in the approach section. So in Accenture, you will just have to implement the function. You do not have to worry about any inputs or anything. So we have got two inputs in this function, that is n, the number of barriers, then the array, which will contain n information of n barriers, and it will have three columns only, that is x, y, and d it will contain. Now, as I have told you, as a step 1, what we have to do, as a step 1, we will have to find the starting and ending x points of each and every barrier. So if there are n barriers, we will have to find the starting and ending x points of n barriers. So for storing those values, we have to define an array, that is int points. It will have n rows and it will have two columns which will store the starting and ending x value. Okay, then we will initialize this array with 0 initially. Now then our step 1 starts. So as I have told you, in step 1 we will have to find the starting and ending x point of each of the barrier. And how we will find that? The starting point will be the xi, that is this one, and ending point will be xi plus d. Okay, so starting point will be the xi only, that is ARR of I0 only, and the ending point of the barrier will be, that is the ending point will be stored at the second column, that is I comma 1. Okay, it will be the xi, that is error of I comma 0, plus the d, and d we all know it will be present on the third column of the input array. So on the first column of the input array, x value will be present. On the second column of the input array, y value will be present, and on the third column of the input array, d value will be present. So we have found the starting and ending point of each of this barrier, and we have stored it in the array of points. Okay, we have stored it in the array of points. Now remember the step 2. Now we have the starting and ending point of each of these barriers. Now we will check for overlap, and once we have found the overlap, we will merge those two or those three barriers. Okay, so for starting, we have took first barrier as our initialization. So we have taken 2 points, start x and end x. Okay, and we have initialized the value of these two variables with the starting point and ending point of the first barrier. Starting point and the ending point of the first barrier. Okay, now we will be iterating over the points array from the first index, because from the 0th index we have taken the initializing value, and from second barrier we will be starting iterating. So we will iterate second barrier, then third, then fourth, then fifth, and the value of starting and ending in x points of first barrier, we have taken it as an initializer in this particular what we will say in these particular variables, and we are iterating over the rest of the barriers. Now while iterating, we will check for the overlapping. So how we will check? As I have told you, if the starting point of the current barrier is less than or equivalent to the ending point of the previous barrier, it means that overlapping is there. Again, I will tell you, if the starting point of the current barrier is less than or equivalent to the ending point of the previous barrier, then the overlapping is there. So if the overlapping is there, we will update our index with the end value of the current barrier. So what we have done, initially we had, if I will tell you with the example, initially we have start x as 1 and index as 4, because it is the initialized value of our first barrier. Now we are iterating over this barrier, and if our start value of this barrier is less than the index value of the previous barrier, then what we will do, we will it means the overlapping of these two is there, and now we will update the index value, that will be 5. So now our index has become 5. Okay, now if condition is successful, now we will move to the next iteration, that is now we will compare the next barrier. So again, the next barrier is 6, 8. Now we will check whether the starting value of current barrier, that is 6, is less than or equivalent to the index value. So the answer is no here. So 1 comma 5 is there and the answer is no. So it means that the overlapping that was happening before it, before this current barrier, we have already found. So this is the overlapping that was happening from 1 to 5, it was overlapping happening. So in this case, this first condition is not fulfilled. We will move towards the else condition. Now in this else condition, we will do step 3 simultaneously. What is our step 3? Step 3 is to calculate the number of people who will be blocked by this particular barrier. That is this particular overlapped barrier, how many people will be blocked from here. And how we will find it? We will do end x minus start x plus 1. So we have done end x minus start x plus 1. So because this currently the start x and end x value will contain the overlapped barrier. Okay, we will contain the starting and ending point of the overlapped barrier. So these are the amount of people blocked. And then now see, our start x and end x value contain 1 comma 5, and now our next barrier was 6 comma 8. So there is no overlapping of 6 comma 8 with 1 comma 5. So it means our work for this particular barrier is over. So now again we will initialize this start x and end x value with the next barrier, that is 6 comma 8. Okay, 6 comma 8 we have initialized. So it means for the barrier that was overlapping at 1 comma 5, our work is over because we have found out total people blocked, and now we have updated the value of start x and end x with the first and second value of the current barrier. Okay, and one it will be continuing for all the barriers, and once this iteration is over, we will again do this particular thing, because let's suppose there was only one point. Then this loop will not run, and we will simply find out total people blocked by that single barrier by this particular thing, and in the end we will return total people blocked. And if I will run this code, I have given these as input, this array as input, and our answer should be 13, as we have discussed in the approach section. So I hope now the code is also clear to you. It is very simple. I have also mentioned the steps also. So what is step 1 doing, what is step 2 doing, and what is step 3 doing, and I have discussed step 1, step 2, step 3 in detail in the approach section. So if you have not looked at the approach section, do check out that also, okay, in this particular video only. So I hope, let's just see what is the result here. So here you can see the result is coming as 13. That is our expected output. So it means that this particular code is running fine, and it will pass all the test cases that will be given to you. So all the whether it is the base case or whether it is the you can say the edge cases, it will cover all. So guys, this video took lot of effort from my side. I made diagram also, and I made this code also, and I made a good approach that you will be able to understand. So please hit that like button and subscribe button for this channel,